Thank you, Krista. I'm Brendon Levitt. I'm a senior associate at Loisos, Ubbelohde, and you get extra points if you can pronounce that correctly. Extra points if you can spell it correctly. We're an unconventional practice that is composed of technically minded architects who assist other architects with large-scale projects throughout the world. We work in various spaces. Most of them all of them relate to visual and thermal comfort, energy efficiency, and decarbonization. We are particularly interested in the ways that light, energy, and the environment create an integrated whole as beautiful buildings that really make spaces or places better. This view that the aesthetic and experiential qualities of the space are just as important, if not more important, to our overall goals of decarbonizing the environment, I think is a little bit rare in the industry, surprisingly. Everybody here wants to make places better. Many people or many disciplines are focused on one part of it or another part. We're trying to provide a bridge among different disciplines. And to that extent, much of our work focuses both on lighting and daylighting, thermal comfort, HVAC systems, as well as monitoring existing buildings to make sure that we're implementing beautiful spaces that are meaningful to people. I think in terms of our practice, we see the number one most important thing to a sustainable future is making beautiful and rewarding spaces. Number one, underline, underline, underline. If we can't do that, then there's no point in putting all of this energy and effort into those places. Secondly, we're trying to maximize comfort in those spaces. Visual comfort, thermal comfort, spatial and material comfort. And thirdly, we're trying to minimize any, what we would call low-hanging carbon emissions. Those include the carbon emissions associated with actually, let me back up. Before the carbon emissions associated with those systems, it's really before the systems is trying to achieve a measure of autonomy for the daylight systems and thermal systems. And if we can enable a building to work autonomously on its own, working with the ambient microclimates, then it creates less pressure on the systems themselves, the lighting, heating, the cooling systems, which are the bulk of the carbon emissions associated with buildings. And then as we drill down into now some of the more difficult carbon emissions to take care of or handle, we look to embodied carbon. And the reason I say it's difficult is not because it's difficult to find substitutions like mass timber, for example, a well-known substitution, but because we don't have, honestly, a lot of confidence in the EPDs and LCAs that have been published and researched. I think this is a widespread industry problem that they all have been heavily influenced by, let's just say, players with ulterior motives. And our trust in the LPDs or EPDs and LCAs is not high. Intuitively, we know things like structural systems, concrete, are very high in embodied energy or embodied carbon. But other systems and the way that the whole building comes together is less clear in our own minds. And I think before we can say we really should target one thing or the other, we need to have a better understanding of the relative proportion of these things. as we talk about lighting in this context, I think we can pretty confidently say that light fixtures have a very low embodied carbon relative to a building as a whole or society as a whole. But the lighting system, as Matt talked about, the integrated whole of facades and daylight and material and structure and human interaction has a very high relative embodied carbon. So where that sits and how that sits exactly in the sort of spectrum of building is very important to us. We'd really like to know more information. I think the industry as a whole needs to know more. The last thing I wanted to say is specifically about simulation. I put up this one, which is one example of many different simulation types that we rely on in our office. But we find it very important in the context of a practice to be able to simulate things accurately with precision, both for our own confidence as well as the confidence of our clients. So our architects, engineers, owners, facilities managers, it gives everybody to be able to predict how something is going to perform in the future and then show that it performed that way. Gives everybody a lot of confidence, it aligns expectations, and I think most importantly for this discipline, it makes somewhat visible the invisible. And a lot of what we're talking about with decarbonization, with energy, with embodied carbon, embodied energy, embodied operational carbon, operational energy, is about invisible things that people have a hard time valuing. And the more that we can visualize them, make them present in the conversation, the easier it is to have people prioritize them, care for them, and therefore care for the environment that is affected by them. Our practice, as I said, is really focused on these three parts of the overall picture: light, energy, and the environment. And we operate up and down the spectrum of buildings. We're located in Alameda, just across the water there. And this is the approach to our building from the water. We just painted it with this motif that is an homage to some boat building practices that are nearby. Wanted to show off our new facility. Thank you.